So today we are going to be looking at equations of lines. Woohoo! I know, it's exciting. Exciting times. Here we go. Alright, so Unit 2, logical reasoning. We're moving away from that right now and we're moving into linear relationships. We started with that with slopes yesterday. And today we're going to look at two different types of equations that we're going to be using. The first one is called the point-slope equation. It's a useful form of a linear equation anytime you know the slope. And maybe you don't know the y-intercept, but you know this equation has to have a slope of 2/3 and it has to go through whatever point you're given. You can write what's called the point-slope equation. Okay? And when you look at the point-slope equation, you're going to still be able to see what the slope was. And you're still going to be able to see what the x and the y from the point were. Okay? Which means we're not going to be simplifying much. Okay? You're not going to need to simplify much. There's only two things that you would simplify. Okay? The two things you're going to look for to simplify are only simplify double negatives and zeros. And we'll see both examples of double negatives and zeros. Okay? So what that means is when you substitute into this equation, you put the y1 and the x1 in there, and the slope. The only changing you're doing after you substitute in is if you have a double negative somewhere, you need to change it into a what? A positive. And then if you have a zero, you need to do whatever the zero makes happen to the equation. And we'll see that example. Okay? Alright, so let's look at an example. Just like when I did the distance formula, when I went to fill it in with the x1's y1, x2, y2, I wrote the formula and I left blank where I'm going to put in the y1. I'm going to leave blank where I'm going to put in the m. And then x minus, I'm going to leave blank where I'm going to put in the x1. And then close that parenthesis. Okay? So, then I just have to fill it in. My m is 3. That goes in front of the parentheses. My x is 2. That goes with the x. My y is 3. That goes with the 3. We only simplify double negatives and zeros. Are there any double negatives here? Are there any zeros here? So guess what? We're done. That is the answer. You do not do any more solving of that. We don't want it equal to y. We want it to look just like that. The only time this would be equal to y is if y was 0 here and I put a 0 in here, then I would simplify it because y minus 0 we know is y, right? Because when you take 0 away from something, it leaves it the same. Okay? Let's look at the next one. I'm going to do the exact same thing. I'm going to write it a little smaller because I'm thinking ahead and I can see this -4. So I know when I put it in, it's going to go next to a negative sign when I put it in. So I know I'm going to have to rewrite this because I'm going to have that double negative. So y minus, I'm going to do a little smaller. Leave a space for y1. Leave a space for the m. X minus, leave a space for the x. Close my parentheses. And then I just have to fill it in. Where does my slope go? In front of the parentheses. Where does the x value go? Inside with the x. X goes with x, y goes with y. Now, I already have a minus there, but I still need to put that it's a -4. And then my 7, my y goes with y. X goes with x, y goes with y. Slope is out in front all by itself in front of that parentheses. So this time, you see how we have the double negatives?
Yes.
That needs to be simplified. Okay? So I need to write y minus 7 equals 3 parentheses x plus 4. That's it. We're done. Easy peasy. Now here's an example with a 0. Remember I said if we had zeros we're going to have to simplify it, so I know I'm going to have to simplify this one. So I'm going to start real small. Y minus equals parentheses x minus parentheses. I left my 3 spaces. My slope, the -4, goes in front of the parentheses. My x goes with x. My y goes with y. So I don't have any double negatives, but I do have a 0. What is x minus 0? X. So this can be rewritten as just 4 times x, or just 4x, or well, -4. -4x, right? So this is y minus 3 equals -4x. Okay. Number 4. Do you think we're going to have to rewrite number 4? I mean, I do have a negative, but it's on the slope, so I know that's going to go out in front, right? It's not going to go with a negative. And then these are both positive, so I'm not going to have to rewrite this one. Y minus space equals space, parentheses, x minus space, close parentheses. What's going to go in my first blank? 2. Y goes with y. What goes in my second blank? -5. What goes in my last blank? 7. No double negatives, no zeros. I'm done. Now, being mathematicians, we're notoriously good at trying to be efficient. So here's another way you can do it if you don't want to have to rewrite it to take care of, it's not necessarily going to take care of zeros, but you can take care of the negatives as you're filling it in. Because if I'm doing y minus, leave a space, equals, leave a space, parentheses, x minus, leave a space, parentheses. What's going to go into my first blank? -2. So instead of doing a negative, I'm going to do my negative as a vertical on top of the plus. -2. Because I know that's going to turn it into a plus. Does that make sense? So in my brain, I just say negative, but instead of writing a negative, I do a vertical little segment. -2. What's going to go in front of my parentheses? 2/3. And what's going to go in the last blank? -6. And so when I write that negative, I'm going to do -6. I do a little vertical negative, so it changes it into a positive. And then I don't have to rewrite it, and I was so efficient, right?
Hooray.
Oops, I wanted to not do that in black. That doesn't make sense. All right, the next one. Y minus equals, parentheses, x minus, parentheses. What's going to go in my first blank? -6. I'm going to change it into a positive 6. -6. What's going to go in my second blank? -3/2. And in my last blank? -2. -2. So these are called the point-slope form of the equation because when I look back at the equation, I can see what the slope was. I know when I look at this equation up here, line 4, I know its slope is -5, and I can see a point that the line passes through. It passes through the opposite signs. It passes through 7, 2. This one has a slope of -3/2, and it passes through the opposite sign, -2, -6. That's why it's called the point slope, because you can look at it and you can still see what the point is it goes through and what its slope is. Same thing, reason we call the slope-intercept form, because you can look at it and see the slope and the y-intercept, right? What's the problem with number 7? I don't know my slope, but can I find my slope if I know 2 points?
Yes, ma'am.
Yes, I can. We did that all day yesterday. Slope minus minus. Change in y's. What y are we going to put first?
4.
4 minus 1. And so then if I started with the 4, I have to start with the 5 minus negative 3. So again, you could either do, oops, and then I put a 2. You can do like I did, minus a negative 3, or you can use that other technique where you use your minus to turn it into a plus, because we know it's going to really add. So my slope here is 4 minus 1, 3. 5 minus a negative 3 is really 5 plus 3, 8. So my slope is 3/8. Now here I have a situation, right? Because I have 2 points. How do I know which one to use? Does it matter if I use this one or this one, do you think? No. They're both gonna give you the same exact line. So I can say y minus equals parentheses x minus close parentheses. And I can put in, ooh, I didn't leave much room for my slope. 3/8, my slope. And then if I use this first point, my x is a negative 3, so I'm going to make that into a positive 3. My y is a 1, so minus 1. Or, if I do y minus equals parentheses x minus, still 3/8 for my slope. And then I'm going to, my y is 4, my x is 5. If I were to graph both of those equations, let's look and see what happens. Graph those 2 different equations. So I'm going to get a new document. I'm not going to save the old ones. I want to graph. Notice this says f of, or it says f1 of x equals, that's your y, right? So if I think about if I were to just add that 1 to the other side, this would be 3/8 times x plus 3. Close my parentheses. So that's the right-hand side. And then if I just move this minus 1 to the other side, it's like adding 1. So there's that line. And then I want to graph this one. So I just hit the tab button to get my f to a second function. And I'm going to do 3/8 parentheses x minus 5, close parentheses. And then this minus 4, I need to move to the other side, so I'm going to add 4. See how they both graphed the exact same line? I know, right? It's amazing. I love math. Math is so great. Okay, so there are 2 answers. How many do you think you have to give me if this is on an assignment? 1. You only have to give me 1. You only have to give me 1. All right, so number 8, or line 8. I have to find the slope, right? Because they didn't give it to me. My slope equals minus minus. What's going to go on top? 3 minus 5. 3 minus 5? 3 minus negative 6. I'm going to do negative 6. See how I took care of that minus and negative all in one swoop? And then I'm going to have 2 minus 5. So my slope, 3 plus 6? 9. 2 minus 5? Negative 3. So what's my slope? Negative 9 over 3?
Negative 9 over 3.
What's 9 divided by 3? It's negative 3. Straight up negative 3. Don't make this harder than it has to be. All right. Y minus equals x minus, or I'm just going to put both of them. I know we only need 1, but I'm going to put both of them just for our notes' sake. They're both going to have a slope of negative 3. If I use my first point, the x is 5, The y is negative 6. So when I put it in, I'm going to go negative 6. I'm going to take care of that double negative right away. And then my second one, the x is 2. X goes with x. The 3, the y goes with y. So these are my two equations. On an assignment, I'd only have to put one and it would be counted correct. Okay? All right. What do I need to do at 9?
Find the slope.
Find the slope. I'm going to let y'all do that one on your own. Okay? So first find your slope. And then you can write your equations. You can write both of them if you want, just to have both in your notes, or you can just do one. I'll give you about one more minute. About 30 seconds. All right, did we get our answers? What was our slope? Negative 3 over 8. Did you get y plus 2 equals negative 3 over 8 and then x minus 2?
Yes.
Or y minus 1 equals negative 3 over 8 and then x plus 6?
Yes.
Awesome. Let's look at number 10. We're going to do 10 together. So the first thing I have to do is find my slope. So my m is going to be, what are my y's?
4, 4, 4.
So 4 minus 4 over, what goes on the bottom? Negative 7 minus 3. So 4 minus 4 is 0. Negative 7 minus 3 is negative how many? 10. 0 divided by anything is just 0. So last time we had a 0, it was by our x. And so we just took it off and multiplied our slope to the x. But here our slope is 0, so we're going to see how that changes things. Okay? So when I do the first equation, y minus equals x minus. My slope is 0. My first point, my x is 3, my y is 4. So 0 times anything is 0, which means this can be rewritten as y minus 4 equals 0. Okay? Or if I do the other equation, y minus equals x minus, parentheses. My slope is still 0. My other equation, I've got a negative 7, so that's a plus 7. And then I've got a 4. 0 times anything is just 0. So this is really y minus 4 equals. So when your slope is 0, both equations, no matter what points you put in there, they're always going to come out to y minus 4 equals 0. Is this vertical or horizontal?
Horizontal.
Horizontal. It's a 0 slope, not an undefined slope, right? Okay. All right, the next one says, are any of the lines we've looked at parallel? How do we know if any of these lines are parallel? By looking at what?
The slope.
The slope. So I have a slope of 3, 3, negative 4, negative 5, 2/3, negative 3/2, 3/8, negative 3, negative 3/8, and 0. Are any of our lines parallel?
Yeah.
Which ones?
1 and 2.
1 and 2. Are those the only ones parallel?
Yes.
So here's how I'm going to write it. I'm going to say line 1 is parallel to line 2. Notice I didn't write is parallel to. I used my symbol for is parallel to. Are any of my lines perpendicular?
Yes.
5 and 6. 5 is 2/3. 6 is negative 3/2. So positive, negative, 2/3. 3/2. It's opposite and reciprocal. Line 5 and 6. Any other lines?
No.
No. There are some that are opposites, right? These two are opposites, but they're not reciprocals, right? Same here. These two are opposites, but they're not reciprocals. So the only ones that are both opposites and reciprocals are line 5 and 6. So I'm going to say line 5 is perpendicular to line 6. Again, you don't have to write out is perpendicular to if you remember this symbol. Okay, so that's point slope equation. Super simple. This is the one you're used to seeing all the time. Slope intercept equation. So that's your y equals mx plus b. That's the one we're used to seeing. You can, if you're given a point slope form, you can find your slope intercept form by just solving it for y. Which is what a lot of you are just tempted to do anyways with the other one. Some of you, it's like really weird for you to go, wait, I don't have to simplify this further. Because in algebra 1, we always set everything to y for some reason. Okay, so it's just a 3-step process. You have to get y by itself, you have to distribute that slope, and then you have to combine like terms. 3 steps, you're done. Okay, so step 1 is going to be to move that negative 4 to the other side. How do I move the negative 4 to the other side? I add it, right? And so I'm going to do it the mathematician way, which is the efficient way, so I don't have to rewrite the whole thing. We all okay there?
Yes, ma'am.
So now I have to distribute that 3/8 in. So y equals 3/8 x minus 3 times 5 is 15, so this is 15/8. Plus 4. Now here's the problem. I'm going to have to combine the 15/8 with the 4. So I'm trying to think ahead. Because I'm a mathematician, I don't want to have to rewrite this a million times. So I'm going to have like denominators to be able to add them together. What's 4 times 8?
32.
So would you agree that if I write a positive 32 over 8, that's the same thing as adding 4? 32 divided by 8 is 4. Because now I can do y equals 3/8 x. Oops, 3/8 x. That's an 8. And then I just have to combine these two fractions together. Negative 15/8 plus 32/8 is how many 8s?
17/8.
Positive or negative? Positive 17/8. that's it. So now, if I have to graph this, that's going to be difficult for me to graph, because to figure out where 17/8 is on my y-axis, I know it's just a little bit above 16/8, which would be 2. So I know it's a little above 2, right? But I don't know exactly where. And then from that little above 2, I have to go up 3/8, up 3/8, or down 3 back 8, down 3 back 8. So in this case, my original equation would have been easier to graph, because I know I go through +5, +4. So I'd put my first dot at 5, 4, and then from there, up 3/8, up 3/8, up 3/8, or down 3 back 8, down 3 back 8. Okay, so sometimes it's easier to graph this if your y-intercept isn't a nice, pretty whole number. Okay? All right. Line 2, if I kind of follow the same pattern that I did on line 1, what is the first thing I'm going to do? I'm going to add the 3 to both sides. So when I add it to this side, it's going to cancel out, and then I'm going to add it to this side. What's the next step I'm going to do? Distribute that -3. I have to get rid of the parentheses. Y equals -3x plus 6 plus 3. Combine like terms, so y equals -3x plus 9. That's an easy one to graph. Start at 9, go down 3/1, down 3/1. Or up 3 back 1. Number 3, what's the first thing I'm going to do? Subtract 2 on both sides. What's the second thing I'm going to do? I can't combine like terms, so I get rid of parentheses. Distribute the -3/8. Y equals -3/8x plus, what's 3 times 2? 6/8. Which I can reduce, but I don't want to have to deal with that because I don't want to have to rewrite it. So I'm going to leave it at 6/8. When I bring down this -2, I want it to have the same denominator as my 6/8. What's 8 times 2? 16/8 is the same as 2, right? So then y equals -3/8x, bless you, plus 6/8 minus 16/8 is -10/8. So that one I am going to have to rewrite it one more time because I need to reduce that fraction because 10/8 is reducible or simplifiable. Y equals -3/8x minus, what is 10/8 reduced to?
5/4.
5/4. Okay. All right, what am I going to do on number 4? I'm just going to add the 4 to both sides. I don't have parentheses to get rid of, so I'm just going to do y equals 4. Is that a vertical or a horizontal line? I don't see a slope.
Horizontal.
Horizontal. What is a vertical line? Do you remember what the equation for a vertical line looks like?
Undefined.
It is undefined. What is it? It's e. But you can write an equation. It doesn't have a y in it. So what other variable is there? So a horizontal line is y equals a number, and it's horizontal at that number, so this one goes through 4. A vertical line would be x equals a number, and it goes vertically through the x-axis at whatever number x equals. Okay? So I know that's a vertical line, which means this one has a slope of, what's the slope on this one? 0. You could think of it as over 1 if you wanted to, because later we're going to be looking for the perpendicular, so we're going to need to flip it over and change its sign. All right. Writing an equation in slope-intercept form given the following information. Number 5 is pretty simple, right? They gave me the m, they gave me the b. Whoops. So y equals mx plus b. y equals, what am I going to put for m?
1/2.
1/2. X plus b, what's my b? 5, a positive 5. Easy peasy. Number 6, they gave me the m, they gave me the b. So y equals, what's my m?
Negative 1/2.
Negative 1/2. X plus b, what's my b?
Minus 5.
Yeah, should I put plus a negative 5? No, because we want to simplify it. So I'm going to just put minus 5. What do you think I need to do on 7?
Point slope form.
I have to put it in point slope form first, and then I have to do like I did on lines 1 through 4 to solve it for y. So the first thing I'm going to do is y minus equals parentheses x minus. What's going to go in my first blank? 3, my y value. What's going to go in my second blank? 2, slope. What's going to go in the last blank with the x? 4, my x value. No double negatives, no zeros. I don't have to do anything with that. So now I just have to actually solve it for y. What's the first thing I'm going to do?
Add 3.
Add the 3 to both sides. Then what am I going to do?
Distribute.
Distribute. Then what am I going to do?
Combine the terms.
Combine like terms. Negative 8 plus 3?
Negative 5.
Negative 5. Easy peasy.
Couldn't you have substituted couldn't you have put it into slope-intercept form? And,
That's what we did, is put it in slope-intercept form. But they didn't give us the intercept. They gave us 4, 3. So I had to put it in the point slope form first. So first I did that. I put it in the slope-intercept form. And then from there, I solved it to set it equal to y.
I don't know how to explain what I did.
Let me see. Oh, you substituted in x and y. So here's what she's done. Okay, this is another way to do it. That's perfectly fine. Y equals mx plus b. We know the m is 2, but we don't know the b. We do know an x and a y. So we substituted in for y, we substituted in the y. And for x, we substituted in the 4. And so then the only variable I had was b. So we solved this and got b was negative 5. So then once I know the b, I can rewrite the equation y equals m2 x minus 5, because that's my b. Does that make sense? Both ways work. Yes,
Okay.
Substitution works as well. Okay? You can do it either way. So for number 8, do you want to do it with point slope form or do you want to do it with substitution?
Substitution.
Okay, let's try with substitution. So I know the m, I don't know the b. So if I look at y equals mx plus b, so this is just another way to solve it. My y value that they gave me is negative 9. I'm going to substitute that in for y. My slope is negative 2. My x is 7. Be careful if it's a negative that you make sure you put it in parentheses and make sure you add the negative. Plus b. Negative 2 times 7.
Negative 14.
Negative 14. How do I solve this? For b.
Add 14.
Add 14 to both sides. Negative 9 plus 14.
3.
Negative 9 plus 14.
5.
So now I know my slope is negative 2. My y-intercept is 5. I can write y equals mx plus b. So both of those systems will work. Both like we did on number 7 and both like we did on number 8. They'll both work every single time. Okay, good. Now you have 2 ways to do it. You only have to do it once. Alright, so now we're going to do just like we did on the last page. We are going to decide if we have anything parallel or perpendicular. So if I identify all my slopes, 3/8, negative 3, negative 3/8, 1/2, -1/2, 2, and -2. Are there anything that are parallel? Any parallel lines? No, none of those slopes are the same. Are any of the lines we have looked at parallel? No. None of those lines are parallel. What about perpendicular?
Yes.
Yes, which ones are perpendicular?
8 and 5.
8 and 5, -2 and +1/2. That's correct. Line 8 is perpendicular to line 5. Or we could have put them in numerical order. Line 5 is perpendicular to line 8. Any others?
6 and 7.
6 and 7, -1/2 and a +2 are opposites and reciprocals. So, and line 6 is perpendicular to line 7. So there's 2 sets that are perpendicular. There are no sets that are parallel. Okay, your assessment for today is in Schoology. Awesome.